We're going to talk about the end behavior of polynomial functions, which is what happens as x goes to infinity or x goes to negative infinity. We're going to do 4 basic graphs to start with and then extend it to all polynomials. Okay, let's talk about x cubed first. The graph looks something like this. So your end behavior when x is really, really large or really negative large is like that. Up on the right, down on the left. Now y equals negative x cubed. That negative flips the graph around the x-axis. So our end behavior is this. Now let's try an even exponent, x to the 4th. That graph looks like this. So our end behavior would be going to positive infinity on both sides. And then if we flip that graph upside down, we have the end behavior that goes to negative infinity. We want to find the end behavior of this graph. Now when x is really, really large, your negative x to the 11th term will dominate the 2 and the pi x squared. It will be so much bigger than them that we don't have to worry about it. So we just say that it's approximately negative x to the 11th for large absolute value of x, either direction, positive or negative. So let's analyze the end behavior of negative x to the 11th. If we have a really large positive number and we take that to the 11th power, it will still be positive, but then we have the negative out front, which will make it negative. So we're going down. Now let's put in a large negative number. A large negative number to the 11th power is still negative. Put that negative out front of that, it makes it positive. Now notice this is the same end behavior as negative x cubed. Let's find the end behavior of this function. Now we don't want to multiply this all out, but all we need to know is its degree. So that's the x to the highest power is going to dominate this function when x is really, really large or really, really negative large. So let's start out, we're going to have a negative 5 times x. Okay, this one, when we FOIL it out, the dominating term will be a negative x. This one, when we FOIL it out, it'll be an x squared. This one will have a 7x to the 6th. And let's further narrow that down. We have a negative, okay, and then we have a negative cubed, which will be negative again. So that's going to make it positive. The 7, it's just positive. Then we have our x's. We have x, we have an x cubed, so we're up to x to the 4th, times x squared, so we're up to x to the 6th, and another x to the 6th, so we'll have an x to the 12th. So let's find the end behavior of that. Well, let's take a really big positive number to the 12th, it's still going to be positive. If we take a really big negative number to the 12th, it will still be positive because a negative to an even power is positive. Notice this is the same end behavior as x to the 4th. So let's generalize. If our degree is odd and our coefficient of that term is positive, then our end behavior is going to look like x cubed. And then if there's a negative coefficient, that'll flip it and it'll look like this. If it's even, will look like x to the fourths in behavior, and if we have a negative coefficient, it'll be flipped around the x-axis.